Hi, I'm Rajan Patel. My teammates are Sankalp and Rahul, and we have worked on surveying and analyzing different machine learning and deep learning models for malicious URL detection. A malicious URL is a web address that leads to a harmful or malicious website. These types of URLs are often used by cybercriminals to trick people into visiting their websites, which may contain viruses, malware, or other harmful content. Malicious URLs can be distributed in many different ways, such as email phishing, malicious ads, malware, social media, shortened URLs, etc. There are different elements of a URL as shown in the poster, such as protocol, which is used to access the resources of the web server, domain name, which can be divided into three parts, subdomain, secondary level, and top level domain, the resource directory, and the requested web page to access content of the page.
So some examples of malicious URL detection techniques are blacklisting, rules-based techniques, and machine learning and deep learning methods. We mostly use machine learning and deep learning methods today because they generalize well to new data. Machine learning methods require manual feature engineering. Some of the popular features used are lexical features, host-based features, and content-based features. They have different pros and cons as listed in the poster. So now how do we measure the performances of these models? So we are using the AUPRC metric. It is area under precision recall curve. So precision tells us the quality of the positive predictions. Recall measures the model's ability to detect the positive samples. It is more important for us to detect the false negative rate because the damage that can happen by not detecting a malicious URL is more than the damage that can occur because of false positives. So we use the AUPRC metric. We calculate the AUPRC metric by calculating average precision.
So for our survey, we implemented various machine learning and deep learning models for lexical based, domain, and a combination of these features. From the graph, it is clearly seen that the combination of all these features perform better than the standalone features. Moreover, it is quite evident that deep learning models perform much better than machine learning models. Some interesting things that we found out were that lexical features are most utilized inputs to these models, but they can be easily manipulated. So hybrid features are used to make these models more robust. Moreover, adversaries use different methods to conceal malicious URLs, like obfuscation, encryption, and manipulation of lexical features. So using existing features might not always help in solving these issues. So deep learning models offer a better approach as they keep finding better features. Our experiment showed that deep learning techniques perform better than machine learning models. We also found out that using a combination of lexical features and domain-based features improved the performance of our models.